So let's extend this game we're playing with inverse functions to come up with expressions for derivatives of the inverse trig functions. The first inverse trig function whose derivative we'd like to determine an expression for is the arctangent of x. In particular, we're considering the principal arctangent function. And if you'll recall, that's the inverse of this function f of x equals tangent of x, wherein x is restricted between negative pi over 2 and pi over 2 exclusive. So if this is f of x, its inverse will be g of x equals arctangent of x. So here you can see the range lies between negative pi over 2 and positive pi over 2, exclusive of both. While the domain of arctangent of x is negative infinity to positive infinity. And this corresponds to the range of our domain restricted tangent of x function. Recall that we know if f of x and g of x are inverse functions, and if f of x is differentiable over ab, then its inverse g of x is differentiable over the open interval f of a to f of b. In this case, we have f of x is tangent of x, differentiable over the open interval negative pi over 2 to pi over 2, and thus its inverse g of x equals the principal arctangent of x is differentiable over the open interval tangent applied to negative pi over 2 and tangent applied to pi over 2, which amounts to the open interval negative infinity to positive infinity. So in essence, the g of x is going to be differentiable over the range of f of x, provided that f and g are inverse functions of x. Realize that this circled statement here, this circled implication here, is equivalent to the implication that if g of x is differentiable over the open interval CD, then its inverse f of x is differentiable over g applied to those endpoints of the interval that we just spoke about. So over the open interval g of c to g of d. To illustrate that, here we have g of x differentiable over the open interval negative infinity to positive infinity, but f of x is differentiable over the open interval whose endpoints are, or whose bounds are g applied to each of those. So in this case, arctan isn't really defined at negative infinity or positive infinity, but the limit of arctangent of x as x approaches negative infinity is negative pi over 2. The limit of arctangent of x as x approaches positive infinity is pi over 2. So correspondingly, f of x is going to be differentiable in the open interval negative pi over 2 to pi over 2. So knowing where f is differentiable, we can figure out where its inverse g is differentiable, but what exactly is its derivative? If you recall from a previous video in which we found the derivative of ln of x using the derivative of e of x, the derivative of an inverse function, g of x, denoted as g prime of x, is 1 over the derivative of f evaluated at g of x. In this particular case, we have the derivative of arctangent of x is 1 over the derivative of the inverse of its inverse, which is tangent of x, but evaluated at x equals arctan of x. But that's 1 over secant squared of x evaluated at arctan of x. Hopefully you remember from your trigonometric identities that secant squared of x is 1 plus tangent squared of x. If not, you can divide both sides of the Pythagorean identity, the base Pythagorean identity, which is 1 cosine squared plus sine squared equals 1, or 1 equals cosine squared plus sine squared. You can divide both sides by cosine squared of x. This will become secant squared of x this term will become 1, and this term will become tangent squared of x. And if you evaluate 1 over 1 plus tangent squared of x at arctan of x, what will you get? Well, if you plug in arctan of x where x is, this denominator will be 1 plus the tangent of arctangent of x quantity squared. So you'll have 1 over 1 plus the tangent of arctan of x, the quantity squared. Because remember, tan squared x is just tangent of x, the quantity squared. But when we have tangent of arctangent of something, it's basically saying arctan of x is asking, well, what angle's tangent is going to give us x? And then if we go ahead and take the tangent of that angle, we'll get x back out. So we're just left with 1 over 1 plus x squared. So this is the derivative of the arctan function. So I'll just go ahead and write it here. Arctangent of derivative with respect to x of arctangent of x is 1 over 1 plus x squared. And we can go through analogous procedures to derive expressions for the derivatives of the other inverse trig functions. So in the next video, we'll go through a similar procedure to find the expression for the derivative of the arc cosine function.